Welcome to AP Computer Science B Term. We're looking at Unit 3, Assignment 3.00, and this is located in Chapter 6. Today we're looking at 5 exercises, all written inside the string info class, except for the last one, which is you're just going to write an explanation. Exercise 6.32. Write a string info method, public int last biggie, and in the parentheses string info par. The executor returns a last position at which it has a character that has a larger Unicode than the character of the parameter at the same position, and give them a -1 if there's no such character. And it throws an exception if par is null. If you took Programming 2, you had a section on throwing exceptions. And you remember you had to have the try block, the catch block, and the finally block. You can have a review at docs.oracle, and it goes into a little more details on throwing exceptions in here. But for our particular case, all that you need to do is to add it to this main statement. Once again, all these methods are inside of the string info class. So what we're going to do in this particular exercise 6.32 is we're going to put it right into the statement here that it throws an exception. And all this is doing is it's going to keep it from crashing if the user doesn't enter anything. See, par is equal to null. And you're going to put into here throw. See, here you have throws, and you got to use throw. You're going to have a pop-up say invalid parameter. So that's what you're doing. You're taking care of this here. It throws an exception if par is null. So we're taking care of that at first. You're just putting this extra on the end of public int last biggie string info par. Okay. Of course, it says here, if this is the case, we'll give the integer a -1 if there's no such character. So that's what we have here. Otherwise, we pop out. So in this particular case, what are we looking at? We're going to run a loop. And what we're going to say in this loop is that we're going to look at the length of the string here. See, itself is the name of the string. Okay, and whatever's in here, par, we're looking at the index of this particular string as well. We're comparing two strings, right? As long as the index, or how many times you go around and around the loop, is less than the length of the first string, as well as the index being less than the length of the second string, we're going to increase the index. We're going to bump it up every time. That's what we set up. That's the condition. So we're checking both strings at the same time. So we're looking for the executor returns the last position number at which the character that has a larger Unicode than the character of the parameter at the same position at the last position number. Okay, what are we talking about? What's Unicode? Computer number of a particular digit. Okay, remember we have digits A through Z and capital A through capital Z, white spaces, symbols, Chinese letters, all that stuff, right? All those particular symbols and letters and numbers have a Unicode representation that the computer recognizes. So in order to sort, you have to refer to the Unicode. We're just doing a sort of a kind. So we're looking at this particular string. If the first string at this particular position is greater than the other string that has the character at the same position, what are you going to do? The position is this particular index number. you're going to do the last position number. So it's going to pop up only if this condition is true, correct? And so in the end, you're going to return that variable. Okay? And that'll meet this code here. Exercise 633. Write a string info method, public string info reverse. The executor returns a new string info value of the same length, but with the characters in reverse order. Hint, you cannot assign a new value at a particular index of a string, but you can concatenate characters onto a string one at a time to get what you want. Exercise 633. In this one, we're going to write a string info method, public string reverse. And the executor is going to return a new string info value of the same length, but with the characters in reverse order. So what we're going to do is we're going to create a temporary string. We're going to call it temp or something like that. And we're going to add the digits in reverse order. And the way we're going to reverse it is we're going to use a loop. We're going to go to the last digit and we're going to chop off one off the end of this character loop until we get to the initial position. Okay. We're going to concatenate the characters as they come. And that'll put it in reverse order, all right. So what does that look like? All right, so we're going to declare our method, public string reverse. So we're going to create our string, we're going to call it temp, and we're going to load it up with nothing. It's going to be blank initially, okay? And of course, the length of the string itself is -1. In other words, you have to have something in there, so we set it up at -1. All right, because the first character will be 0, won't it? All right. So you have to put it at -1. All right, so we're going to go while length is greater than or equal to 0. Okay, so that's this number. What are we going to do? We're going to take that temp and we're going to add to temp the last number in the string. See, like I said, as we go down, we're going to chop one off. Character at, remember the character at, and whatever the length of the string is. Okay, it's the last position in the string. We're adding it to temp, and then we cut it down by 1. See, we cut the length down by 1. So in the end, we put temp in as itself, and then that's the string in reverse order. Okay, that's the method, and we return it. Exercise 6.34. Write a string info method, public void replace, and in parentheses char low, char high. The executor replaces every instance of the char value low by the character value high and makes no other change in itself. Now we're doing something very similar in exercise 6.34 as the last one, 6.33. We're going to be taking number letter by letter, and we're going to be looking at if we have this particular value that we call low, and we're going to replace it with the letter high. And what we do is we add the letters to the new string one at a time unless we come across a particular character here. So it's pretty simple and straightforward, okay? So once again, we call the method replace, and with our 2 characters. So, we look at the string's called itself, of course. And we have to say, okay, what if it's nothing in it? We return nothing, right? So that's handling the null case. Otherwise, what do? You're going to chop up that string. So you're looking at each individual string, each individual character in that string. And you're looking at, as long as I is less than the length of the string, you're going to increment I each time you go through the string. All right. So the first thing you're checking to see is if we're running into this character we call low. If that's the case, we're going to replace it with the character called high. So the new string in that particular instance, you add on a high instead of adding on the regular character. Otherwise, you just add on the regular character. And eventually, you have to come to the end of the whole process, and the new string is whatever it is. See, very simple. So it just takes the simple if-else statement. Exercise 635. Write a string info method, public void num words. The executor tells how many words it has. And it has in parentheses, a word is a non-white space followed by either a white space or the end of the string. What we're going to do in this particular exercise is we're going to look for empty spaces. We're going to look for blanks. And every time we come across a blank, we're going to add to the number of words. And then, of course, we have the last condition is we come to the end. There's always going to be at least one word, right? So we're going to be counting white spaces, basically. How do we do that? The same way we've done the previous exercises. We're naming the method num words. We have two variables here. We can't start the count at 0. And then we have a method called trim font. And what this does is it trims all the excess stuff, that might be paragraph marks and whatever, from the beginning of the string. That's what this trim font does. It's a method that we have in this class. Then we instantiate the last white space method, and we set it to false. Okay. So now we put our loop in here. We're using a for loop. As long as we start out in the beginning with I at 0, and as long as it's less than the length of the string, we're going to just add 1 to the particular character. So we're going to call whatever character we're at as current, and that's wherever the particular index is at. So what about that? So if it's blank and you have the last white space is equal to false, you're going to turn it true, and you're going to add 1 to the count. So we just found another word. Okay. So if the current is not equal to an empty, the last white space is false. So then you pop back through this until you run to the end of the length. At the end of the length, you're going to have the last add-on. So that will give you all your words. Okay. You wouldn't necessarily know this. This trim font takes care of anything before the first words come in. So there you go. And last but not least, Java has its own analog of the Y2K bug. In what times and dates will be messed up when the current time exceeds the capacity of a long value? In approximately what year will that happen? Okay. Well, the first thing you need to know is what the Y2K problem was. Basically, years used to be represented as the last 2 digits. And what happens when the years are represented as the last 2 digits is when you came to the year 2000, there was a problem. There's an issue. So A lot of programs, didn't have anything to accommodate this. And a lot of big programs. So um, all everybody had to go back through their stuff and make sure that this isn't going to be a problem. So some silly things happened, like talking about Windows 3. So what happened with Windows 3? Instead of going to 2000, the next character was a colon. The next Unicode character was a colon, so it went, colon 0, 19 colon 0. So the solution was to go to having a time as a 32-bit to having it as a 64-bit alternative. So another thing we need to check out is how much is a long value. It ranges up to plus or minus 2 to the 63rd power. And you find this on page 6.6-20. So I have to go back and I have to figure out what the book author was trying to think of when he had this particular exercise in mind. And I'm thinking, how do you compute Unix time? How many seconds have passed since midnight, January 1st, 1970? Now, I suppose you could do this from 1900. I don't think it would make a whole lot of difference because it's a humongo number you come up with. So this is a code for that, and this is not important, but I did want to show you that it is a long number. Also, you notice that this is measured in seconds. Okay, so we're going to assume we're going to measure in milliseconds the number of milliseconds that have passed since midnight of January 1st, 1970. So you see the method might look something like this. You can put whatever you like. System current time, min, n is, that's just arbitrary there. You can put what you want. So it's going to give the current time measured in milliseconds that have passed since midnight of January 1st, 1970. Once again, this is kind of arbitrary. You could put January 1st, 1900 if you prefer. But it's not going to give that much difference because the number's humongo, okay? So you figure what? A long value is 64 bits long. We learned that. And it's in a range from 0 to plus or minus 2 to the 64th power minus 1. Okay. So we're doing a calculation here. How many milliseconds are in a year? So we have 60 seconds in a minute times 60 minutes in an hour times 24 hours in a day. And then we add what? So that's how many seconds there are in a day. We're going to multiply this times 1,000. So there you go. And now we're going to multiply this times 365. That's how many milliseconds are in a year, okay? So the number of years is going to be 2 to the 64th power divided by the milliseconds in a year. Okay, so that's going to be equal to 585 times 10 to the 6 years. So what do? I just put in the calculation into Google, right? So 2 to the 64th power divided by this long number. And what I did is I took it to my calculator and I went edit copy and I just put 2 to the 64 power divided by that. And this is the number it comes up with. Or you can represent it in another way. It happens after 585 times 10 to the 6th power plus 1970 years. Okay. So you can represent this as 585 times 10 to the 6th power. 1, 2, 3, 4, 5, 6, right? Just round that up to 585 times 10 to the 6th power. I think that's all the explanation you need for your solution. You're ready to turn everything in.